Do you ever get impatient with this stuff? You know, you feel you're aging, you're getting old in age, you watch your kids go to college, that sort of stuff. Someone's going to make a great, you know, prove your theory, make a great discovery. Are you going to not be there for it?
I think we all have to come to grips with the fact that we probably won't see everything we'd like to see.
And what would you like? What would you like to see? What would you die a happy man? What particle? What would you like to see happen?
Oh, I'd like to know how string theory really works. What are the concepts that improve upon Einstein's concepts by which it fits together, and how it applies to the real world.
Is having intuition, the fact that Einstein could view a lot of the stuff in his mind without needing the math for it, is that an important thing for you too?
Well, we all try to see things with intuition, because if you have to step through every detail of the equations, it's just too complicated. But generally speaking, none of us are as good at that as Einstein was. So Einstein made amazing leaps that were based on intuition. And honestly, I think that string theorists have made a lot of nice discoveries in the last 30 years. But it's usually been made by working incrementally within an established framework until things fit together a little bit better, and then finally you get a better view. It's a little bit more like climbing in a mountain range or hiking through mountains. So you take one step after another, and finally, after one more step, you suddenly reach the top of the mountain pass and you get a completely new view of the other side. But the last step in and of itself wasn't any more difficult or more remarkable than 10,000 steps before it.
When I was a kid, I used to like to play with stuff in my basement. I used to take stuff apart, TV sets, all kinds of stuff, because I knew I was interested in science.
Yes.
I wanted to know how things work. Were you that kind of kid?
I actually never played with electronics that much, some science kits. As a kid, I wanted to be an astronomer, and then at a later age, I thought I'd be a mathematician. And then I dabbled with a lot of things eventually. But my natural talent was in math and physics, so that's where I ended up.
But you were a history major at Brandeis, right?
Can't deny that one.
Well, why would you want to deny that? You wouldn't really want to deny that.
No, I wouldn't want to deny it, but let's just say that for a while I was interested in history and linguistics and other things, but my natural talents really brought me back in the direction of math and physics.
Is it just curiosity? I mean, you must need a lot of curiosity to feed yourself in this business, to feed mental energy.
Well, it's curiosity, but one thing I find is that when I want to relax, I enjoy reading things that aren't necessarily about physics, or at least not about the kind of physics I do. But it's more fun for me to read things that are true than to read a novel. So I would much rather read magazines on archaeology or magazines on astronomy, even though they might be written for amateurs. After all, I'm a little bit of an amateur astronomer. My son and I have got a telescope. We go out and look at the skies.
I'm with you. I got one also. I go in the backyard and look at the stuff. And you ever look at the moons of Jupiter?
Yes.
And aren't you suddenly have a mind meld with Galileo when you're doing that? I get this feeling. I know exactly the excitement that he had when he saw.
It's exciting to see it, but it's hard to imagine fully how exciting it must have been to see them for the first time.
Yeah.
So I try to imagine it sometime, but it's hard to fully imagine.
Your job is tough enough. I mean, having to synthesize ideas, and especially in a world in superstring theory and string theory where there's not a lot of data
Yes.
to go on. So what keeps you going? I mean, getting out of bed and continuing.
We don't have so many clues, but they're big clues, like the existence of gravity, the fact that string theory makes gravity inevitable, while the pre-string framework of physics actually made gravity impossible. We've got some big clues like that. Another big one has to do with hints from accelerator experiments that supersymmetry is beginning to appear. So we don't have a lot of little clues, but we've got a few big ones. My colleague Steve Weinberg always used to say that sometimes physicists are like elephants who eat lots of food of very low nutritional quality, and sometimes they're more like lions who only eat now and then, but their meals have a very high nutritional value. So obviously, as a string theorist, one has to work a little bit more like a lion than an elephant. But that's life.
Mm-hmm. And some people say this is so esoteric that there are doubting Thomases out there that this could be true. Is that correct?
Well, people often ask how such an ambitious theory as string theory could ever be completely tested. Maybe you could test a big piece of it by discovering supersymmetry, but string theory is even more ambitious than that. And how could you ever really experimentally probe all that. But the whole history of physics shows innumerable times when theories that looked like they'd be impossible to ever test were tested. If you go back to the 1930s, you'll see that gravitational waves, black holes, neutron stars, and even neutrinos were big ideas that all seemed practically in the category of science fiction, because nobody could imagine how any of them would ever be tested. But then, by the 60s and 70s and 80s, they in fact all were tested, and some of them are now used routinely as ingredients in other experiments. So in many cases, they were tested because of other discoveries that were made that weren't foreseen. Other things happened. If you could foresee everything that's going to happen, science wouldn't be so exciting.
Let's talk a little bit about this institution. I feel like the ghosts of the past people are here. You know, the ghosts of the Einsteins, other people who have come beforehand, and that there's sort of an expectation to be a great person because you're here. Do you feel that kind of, those ghosts?
Well, it's best to not worry about that kind of thing too much. You do the best you can, and probably you can't live up to some of the precedents of Einstein and some of the others who were here in the past. But you can still have fun and contribute something to science.
And that's great as long as you're having fun.
Don't worry about that one.
I mean, is fun
It's
part
the
of
best job in the world.
it? You get paid for doing something you love.
Yep. The only bad part is when you get stuck, which happens plenty. But
How do you get yourself out of a rut? Is there something that can spur
There's
you to
no-
go bowling or something to get your mind up?
if there was any one thing that always worked, of course we'd do it, and then we wouldn't have been stuck. It's a little bit like asking how the scientific problems are going to be solved. So we never know that, or we would have solved them already. And then they wouldn't have been that interesting. The really interesting ones are the ones we don't know how we're going to solve, and therefore we don't know when we're going to solve them. So you try to learn something new, you talk to somebody you haven't been talking to, you read a paper you hadn't paid much attention to, you hope to get lucky. Maybe one of your colleagues will have a good idea and you can latch onto some secondary aspect of that.
Do you worry about running out of ideas?
Well, it's going to happen to all of us eventually, but we can have fun in the meantime.
Why do physicists have their best ideas in their 20s?
Well, I would like to say that that's not entirely true. That I don't know if I'll manage to have my best ideas in my 50s, but I definitely did better in my 30s and 40s than in my 20s.